Dolphin Group of School, 12th online class, then chapter 6 vector algebra. I can now today discuss with the exercise 6.4, 6.5, 6.7. Be careful, 6.4, 6.5, 6.7. 6.4, the different form of the equation of the straight line is a vector form, is a straight line, and the next one is that the equation of the plane. First, the different forms of the equation of the straight line. First one, parametric form of the vector equation of the straight line. Equation of the straight line equal to r vector is equal to a vector plus t into b vector. A vector is the point, b vector is the parallel vector, where t is the parameter, belongs to r, t belongs to r. This form is called the parametric form of the vector equation of the straight line. The second form, that is AP vector, non-parametric form. The t is the parameter. Now second one is non-parametric form. The AP, the line AP, the point and position vector r vector. R vector minus a vector cross b vector are parallel. The cross product equal to 0. Two vectors are parallel, a vector plus b vector equal to 0. Therefore, r vector minus a vector plus b vector equal to 0 vector. The equation of the straight line. So, third type, Cartesian equation of the straight line. Three types: parametric form, non-parametric form, Cartesian form. That is x minus x1 by b1 equal to y minus y1 by b2 equal to z minus z1 by b3. Where b1, b2, b3 are direction ratios. That is the parallel vectors. x1, y1, z2, z1 is a point. Be the point. b1, b2, b3 are parallel vectors. Okay. Now, straight line passing through two given points is one point, one parallel vector. The second type is two given points. R vector is equal to a vector plus t into b vector minus a vector, or r vector is equal to 1 minus t into a vector plus b vector. Any one type we can write. R vector equal to a vector plus t into b vector minus a vector, or r vector is equal to 1 minus t into a vector plus b vector, where t is equal belongs to r. A vector and b vector are two given points, very important. Then second type is non-parametric form. R vector minus a vector cross product, r vector minus b vector equal to 0 vector. Third one is the Cartesian form of the equation. X minus x1, 2 points are x2 minus x1, y minus y1 divided by y2 minus y1 equal to z minus z1 divided by z2 minus z1. The given points are x1, y1, z1, x2, y2, z2. This form is called the Cartesian form. Right. Then second one, angle between the two straight lines. Cos theta equal to b vector dot d vector divided by modulus of b vector into modulus of d vector, where b and d are parallel vector. Where b and d are parallel vector is the dot product. Angle between the two straight lines. So a1, a2 vector is the 2 points. B and b vectors are parallel lines. Now, note, very important note, 2 is the theta equal to 0, cos theta equal to 1. Or two lines are parallel. Two lines are parallel. B vector is equal to lambda into d vector. Two parallel vector. One vector can be expressed as some scalar into another vector. Two lines are perpendicular. B vector dot d vector equal to 0. If and only if. Is very important. Two lines are perpendicular. Two lines are parallel. Perpendicular b vector dot d vector equal to 0. So if and only if equal to 0, two lines are perpendicular. Two lines are perpendicular, dot product equal to 0. Cartesian form, that is b1 d1 plus b2 d2 plus b3 d3 divided by square root of b1 square, b2 square, b3 square into d1 square, d2 square plus d3 square is a cos theta. Two lines are parallel, d1 by b1 by d1 equal to b2 by d2 equal to b3 by d3. Two lines are perpendicular, b1 d1 plus b2 d2 plus b3 dt3 equal to 0. Now, the exercise 6.4. Show that the points are collinear. Very important sum. 9th sum. Exercise 6.4. 2 3 points are collinear. Now take two lines, 2 points. This is one equation. And B and C are one equation. The direction ratio of the B and C are x2 minus x1, y2 minus y1, z2 minus z1. That is 8 plus, that is B and C, A and C, minus 2, 1 minus 1, minus 1 minus 2, 4 minus 3, 5 minus 4. Right. Okay. Then next point BC. C 8 minus plus 1, 1 minus 4, 2 minus 5. Two lines are that AB parallel to BC. B is the common point. ABC are collinear. Is the 9th sum. Is very important. And 10th sum, 8th sum. Two lines are perpendicular. Find the value of M. So two lines, equals of the line. Rewritten the straight line. X minus 5 by 5M plus 2 equal to y minus 2 minus y can return as y minus 2 divided by minus 5. Can rewritten y minus 2. And then 1 minus z can be z minus 1 by 1. Minus 1 plus 1. Next one, x is equal to 2y plus 1 by 4m equal to z minus 1 minus z can be written as z minus 1 by 3. X by 1 equal to y. 2 can be divided. Y plus 1 by 2 divided by 2m equal to z1 minus 3. Okay. Then two lines are perpendicular. Two lines are perpendicular. B1, B2, B2, D2, B3, D3 equal to 0. Then multiply this. 5m is equal to 5. 1 is equal to m. Enough. The exercise 6.4 PDF answer. All are very simple.